Let's prepare on the TRB Polytechnic exam 2012 Civil Engineering question paper. Question 116. The force required to cause a rotation theta at the propped end of the propped cantilever beam of span L, Young's modulus E, moment of inertia I is what? So here option C is the answer. Question 117. The reaction of the prop of a propped cantilever beam of span L with UDL throughout it. Then the prop reaction is what? So here option B 3/8 WL. So all these values we will be studying in the strength of materials. Okay. Question 118. A uniform simply supported beam is subjected to a clockwise moment M at the left end. The moment required at the right end of the beam so that the rotation of the right end is 0 is equal to what? So they have given that the rotation of the right end is 0 and it is a simply supported beam. But if the rotation is 0 there it means that it is somewhat a fixed support is there. So let us assume this case, that is the farther end is fixed, means the moment carried will be half, no? So we can go for m/2. Option C is the answer. Question 119. Two plates are connected by lap joint using 4 bolts of 20 mm diameter. If the joint is subjected to a tensile force of 100 kN, the shear stress is what? So here it is the direct multiplication only, that is force divided by area will give you shear stress. So the load is 100 kN, so 100 into 1000 I have converted to Newton, and then area is pi/4 20 square. So pi/4 20 square, and they are given 4 number of bolts, no? So I have multiplied with 4 here. So the answer is 79.6 Newton per mm square. So option C is the answer. Question 120. A timber beam of 150 mm width and 200 mm depth is flitched with 2 steel plates of 10 mm thickness and 150 mm width at top and bottom. The Young's modulus of steel is given and timber is also given. Then the equivalent width of the timber segment is what? So this is the question they have asked. So actually the option here they have given is option B 10 mm. But normally in these cases, if the cover plate is fixed adjacent, means only we can find the answer. So generally this will be a type of thing they will be asking in the question, that is a center thing. So as in this question they have told, no, timber is at the center and steel is at the top and bottom. So generally they will be at the sides only like this. So if this is your timber, means this will be your steel plates. Okay. So as in the question if you are taking, means it is 150 mm and 10 mm, no? But they have given a top and bottom. So top and bottom means I have applied that also, but the answer is not coming. It is more than nearly 500 mm is coming as the answer. But generally let us know what is the steps to find if these type of questions are asked. Okay. So if the timber is having 150 mm width and 10 mm thickness of steel is on the sides of the plate, means the T will be equal to 10 mm, and the depth as it is they have given it is 200 mm. Okay, then the equivalent width will be B plus 2mt. So B means it is nothing but the width. So with this your 150 plus 2 times m is nothing but the ratio of the Young's modulus of the timber divided by that steel. Okay, so always the higher value E should be will on the top and the lower value E will be on the bottom. So here it will be 210 GPa divided by 14 and into T, no? So T is 10 mm they have given. So when you cancel this, the answer will become as 150 plus 300. So the answer will be 450 mm. But in the option, the question itself, it's not given us in the sides, and the option also, this option is not there. So if anybody know how to solve this, means you can share it in the comment. Question 121. The shear stress at the neutral axis of a rectangular beam of width B is equal to D by, so here there is a mistake, subjected to a shear force 100 kN is what? So here actually for this question they have given marks for whoever attempts the question in the key. So because here they have given error, but what actually you should do is the shear stress formula you can apply directly and you can find the answer. So this is the shear stress formula, F into A into Y bar by I into B. So the force they have given in the question, and area also we can find it. So if it is a rectangular thing means B into D you can directly apply. And Y bar is the half, that is the neutral axis depth, so that will be your Y bar. And I for rectangular section it is B D cube by 12 and into B. So you will get the shear stress. 22. The maximum stress of a shaft of 100 mm diameter and 2.7 meter length subjected to a torque of 125 kilonewton meter with shear modulus of 75 GPa is what? So here they have directly applied that ratio T by J is equal to shear stress by R, so that only they have applied here. So this is the formula, T by J is equal to tau S by R. So tau S only we want to find. So it is TR by J. So T is torque. So 125 kilonewton meter they have given. So I have converted into Newton mm. So 10 power 6. And then into 50, the radius, the diameter they have given 100 mm. So radius is 50 mm by J. J is pi by 32 into D power 4. So here D is 100. So when you are getting the answer, you will get 2000 by pi, because in the options they have not used the value of pi, they have kept that pi as it is. So I also kept that pi as it is in the calculation. Option A. And 123, if the wind pressure at a location is 1000 Newton per meter square, wind directionality factor is 0.9 and average area average factor is 0.8. Combination factor is 1, then the design wind pressure is what? So they have given the wind pressure and they have given various factors, so we have to directly multiply it. So 1000 into 0.9 into 0.8 into 1. So you will get 720 Newton per meter square, option B. 124, a propped cantilever of span L is subjected to a concentrated load at the midspan. So if MP is the plastic moment capacity of the beam, the value of the collapse load will be what? So here option B, 6 MP by L is the answer. So this is from the plastic theory concept, and in plastic theory unit we will be studying these values for various type of structures. Question 125. The base plate of a roof truss is attached to the concrete pier with the help of 16 mm dia mild steel anchor bolts of grade FO is equal to 250 MPa. The maximum pull the base can be subjected to if the roof area of bolt is 0.75 times the shank area. So the answer is here 67.5 kilonewton. So this question is actually already asked in the same question paper, and by mistake they have asked it again. So if you want to see the solution for that, means check the question number 38 in the same question paper. Thank you and keep watching.